Hey guys, so here's that video I was telling you guys about. This will kind of walk you through the modules. I'm going to try to start doing this daily, so if you get stuck, you need help, or you want to check your answers and see how you did, because I know we have been running out of time due to the async and synchronous time. But on this problem, you should have found that they were both equivalent. And remember that this square, so this square here, is the same size as this gray square. Well, if I were to shift this, pretend I took those virtual scissors and I moved this into that spot, these two shapes here would have the same exact area. So they would be identical. Okay, I think most of you guys probably understood that one because that was pretty familiar. It's rectangular shapes. Second one, let me get into Desmos here. And again, I'm going to take a peek at your stuff. I'm just really looking for effort and your thought process. All right, so on this one, this was pretty straightforward. If you took the, I'll take the little line tool here. You could have broken it up like this, and then you would have had this up top. This would have been 12 units because it's 4 by 3. That's pretty basic. And then this is 1, 2, 3, 4, 5, 6, 7 by 3. So this one would have been 21. You add those two products up, and you get an answer of 33. Okay, that's one way of doing it. You could have also taken this and you could have broken it up vertically. And then again, this would be a new, this has a new area now because we've cut it differently. This would be 9. And this guy over here is 1, 2, 3, 4, 5, 6, 6 by 4. So 24. And the way I'm getting these numbers, oops, the way I'm getting these numbers is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 6 times 4, 24. 1, 2, 3 times 1, 2, 3. That's 9. Yeah, add those two products up. This is where I get my answer. Okay. Let's see if we got, and then there's also a third way. And this way is a little more complex, but you could have taken and gone outside, and they show you this on the following slides. You could have gone outside. This is an imaginary, so I can't really draw dots here. So I'm just going to draw the lines. This is an imaginary box here, and this would be 9. In this case, though, you would have to do 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. 6 times 6 gives us 36. Remember, this object here is 9, right? So 6 times 1, 2, 3, 4, 5, 6, 7. I apologize. So 7 times 6 is 42, and then 42 would be the large square. This did not exist, so I could subtract this out. So I take away that 9, and that still gives me my 33. Okay, there's a better visual. I know my drawings aren't the best, but here's the visual where we cut it vertically. There's the 9, and there's our 24. We could have cut it horizontally, right? I drew my little line here. So again, you're going to have to do this on test day. You would have to do this on your own. But you have 4 times 3. That gives us 12 up top. And then 3 times 7 is the 21. 21 plus 12, still 33. And then my last one here, this is the one where we did that 42. So we had 42 over here minus the 9. So I had 6 times 7. That gave me my 42. But this flashing piece up here, this does not exist, but we can kind of extend it. That's what I was trying to do with those dotted lines. It does not exist, but if I subtract the 9, I would still get 33. Okay? And here's a visual example of all 3 methods. You choose whichever makes sense to you. There's no right or wrong on that. All right? Same process here. We can cut it here. That gives us 1, 2, 3, 4, 5, 6. 6 times 2. This would be 12. So this would be 12 up top. Or 1, 2, 3, 4. 4 times 3. This would be 12 on bottom. So a total of 24. Same process. I don't have to cut it that way. I can cut it vertically. I take my pencil. This now would be 6 because 3 times 2 is 6. And then 3 times 6 is 18. 6 plus 18, still 24. Okay, and then the more advanced method is you could go outside the box. If you like it, you can use it. Now I have to find the total area of this whole shape if I pretended it was shaded in. 1, 2, 3, 4, 5, 6 by 6. That's 36. And then I have to subtract 36 minus 4 times 3. 36 minus 12. This would be 12 here. So I subtract the 12. I still get 24. So regardless how you attack these, the area is not going to change. This one gets a little creative. So again, let's start off with, we can break it up. I can break it up into a rectangle up top. Break it up like this. And then I would just find each area. Now there's 1 shape, 2 shapes, 3 shapes, 4 shapes. But I still use the same reasoning. 1, 2. by 1, 2, 3, 4, 5, 6. So this guy up top would be 12. Okay? This guy over here is 3 by 2. That would be 6. This guy over here would be 3. So it's 3 by 1, right? This guy over here is 1, 2, 3, 4, 5, 6. 6 by 1. So this would be 6. So 12 plus 6 plus 6 is 12. 12 plus 12 is 24. 24 plus 3 gives us an answer of 27. That's one method. And again, you can cut this up in a lot of different ways. I'm not going to show each and every method, but I just want you, we're decomposing the figure, decomposing it. So if I took this, cut it a different way, cut this part off, cut this part off, cut this part off. Now I have different ones. So 1, 2, 3, 4, 5, 6, 6 by 2. This guy over here is 12. 3 times 2, this guy over here is 6. 3 times 1, this guy over here is 3. And then 6 times 1, this guy over here is 6. So even though we cut it differently, it still comes out. 6 plus 6, 12, plus 12, 24, plus 3, 27. So there's all kinds of ways we can access this stuff. All right. And then you could take this, again, this is more advanced, but you could do 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. I get the entire shape. Pretend that all of this was blue. That would be 36. And then I have a 3 by 3 square in the middle. Well, 3 times 3 is 9. 36 minus 9 gives us that same 27. So lots of ways. And there are videos on this, the same exact things, but I figured I'd teach it to you as best I could. This is where it got a little crazy, okay? But in reality, it's not. We talked about the square. Remember, a square cut from vertex to vertex, literally cut and shaded in half, is a half. So I could literally use two of these. I could use a triangle and another triangle. Oops, sorry. Two triangles to make a square. And it's a little better drawing if I did it this way. So if I look like this, my drawings are horrible on here, I know. I'm just getting used to the program. So if I put this and this together, it would form this. So if I had these two triangles together, it would form this square. So if I glued these two together, half and a half gives us that whole. That was the concept we worked on Friday. We started breaking up that initial object, and then we continued Monday. Yesterday, you actually got to try to find areas, so it's a little more advanced, okay? This case, well, Mr. Fisher, this is not a square. I understand that, but it's the same reasoning. So if I pretended that this is all filled in, so if I pretended this is a rectangle, right? Half of that rectangle is shaded. Well, if I found the total area of this and I cut it in half, that would give me this triangle. So if I find it, this is 1, 2, 3, 4. This is 1, 2. It's 2 units tall. Don't look at the shading pieces. It's 2 units tall by 4 units wide. Okay, pretend there's a rectangle here. Keep that in mind. We're not looking at the triangle. We're looking at the rectangle. Well, 4 times 2 is 8, but I only have half of that 8. So this little guy here is 4. Same concept here. 1, 2, 3, 4. 1, 2. I would pretend there's a rectangle because 2 of these triangles, if I glued them together, make that rectangle. Well, 1, 2, 3, 4 by 1, 2. Again, that's 8. And how much of this is shaded? Only half. Well, half of 8, again, gives me 4. And instead of wasting time, if you notice all these triangles are congruent, so we have a 4, and we have a 4. Because it's 1, 2, 3, 4 by 2. 1, 2, 3, 4 by 2. 2 times 4 is 8. Cut it in half. Okay, that's one method. So you're literally taking each and every area of the triangle. Or you could have moved these. You could take your imaginary virtual scissors and you can move them. So I'll show you a little drawing here. Okay, there's a much better diagram 2 slides down. So instead of me drawing this up and hacking it up, here's that same object, right? Well, instead of trying to draw these out, you can physically move them in your mind. So if I move this piece here, that forms my rectangle. Right? If I take my virtual scissors and I move this shape here, this is what I was trying to explain to you using the diagram. This is a much better example. So here's my rectangle now. It's still all the same shaded area. If I put this over here, it doesn't matter. If I put this over here, like outside of the shape, if they said find the shaded region, you'd find all the blue. Well, it's easier if I make them in shapes that I'm familiar with. So in elementary school, you guys learned how to find rectangles. So this is 1, 2. 1, 2, 3, 4. 4 times 2 is 8. 1, 2, 3, 4. 4 times 2 is 8. And then 8 plus 8 gives us that 16. Okay? So 16. And then our previous slide, this one is kind of crazy because now if you look at the previous slide, right? Same shape, except now the inside is blue. So they don't want these pieces anymore. They want the outside. So this outside piece, right? with this outside piece, I'm going to have to break into familiar shapes. So there's a couple ways we can do this. We can do the reverse negative, which is kind of complex. This is hard, but this takes practice, okay? Studying. So if I took this, this looks exactly like that shape. Well, we already found that this, and this were 4. We found that on the previous slide. We found this shaded blue parts were 4. Well, now they're white, big deal. But I need the blue. So how would I find the blue? Well, now I can look at this entire rectangle or square, whatever it's going to be, and I would shade the whole thing in. Well, it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 times 6 gives us 36. But I only want this blue. Well, this is not included, this guy. This is not included. This is not included. And this is not included. So if I took out 4 plus 4 plus 4 plus 4, or I multiplied them out and got 16, I take my initial 36. Remember, we found the area of the whole shape. If you pretend all this was blue, that would give me 36. We found that all the dead space, the stuff that's not included, is 16. So I took this and I broke it up. 36 minus 16, that gives me 20. Does that make sense? Okay, Ms. Fisher, I have no clue what you're talking about. So here's a different method. I don't like that method. Okay, and again, you can back these up, watch them again. You can re-listen to stuff. So it gets pretty complex, guys, but it takes practice. Okay, you're in middle school, you're not in elementary school anymore. This way is a little more complex. I see shapes inside of the shape. So I could take this, I could break this up into triangles. So the triangles, like this. And then there's a square in the middle. Do I have to find any dead space now? No. But now I have to think about it. I'm like, well, how do I find the area of a triangle? Because this isn't full, this isn't, oh, wait a minute. If I found the area of this rectangle, I know if I pretended all this stuff was shaded and it was blue, 2, 1, 2, 1, 2, 3, 4, 4 times 2 gives me 8. But I only have half. I only have half of it shaded. So if the whole thing was shaded, it would be 8, but I only have half. That gives me 4 again. Well, I know that's the same shape. I know that's the same shape. I know that's the same shape. And I know that because it's 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, and 1, 2, 1, 2, 3, 4. But there's a square in the middle that's not included. So this one's kind of easy. 1, 2, 3, 4, or you could just do 2 times 2. That's 4. So 4 plus 4 plus 4 plus 4 is 16, plus another 4 is 20. Or you could have just said 5 times 4, 20. So hopefully this helps you guys. On the next section, I am going to walk you through those shapes. And we were doing those in class, and those are the ones I really want to see if you're actually getting comprehension. If you're still confused, remember tomorrow morning at 8:30, I'm going to walk through the secondary part of this section and part of 8.4. I'm going to pick some questions, and I'm going to walk through those, and you can ask me individual questions. Tutoring starts at 8:30. 8:30, okay? And we're going to go up until 9 o'clock. Then I'll dismiss you to homeroom, and you're good to go. All right? So hopefully that helps.